Hello and welcome to the Oxford MAT Livestream. My name is James and today we're talking about logarithms. Good to have you with us. I thought I'd start with a fact about logarithms, start with some maths like we always do, that I hadn't really thought about until we did some graph sketching last week. Here's how my fact works. So I've noticed that log of, maybe you already know this, log of ax, let's say, that's equal to log of x, where maybe there's some base down here. What am I going to put for my base? Maybe base b for my base. Log base b of x plus log base b of a. You already know this fact because you know about logarithms. So I've been thinking about graph transformations a little bit. We had an episode last week about graphs and transformations. And so you could think of this on the left as a sort of stretch of the graph of log x parallel to the x direction. And you could think of this thing on the right as a translation of the graph log of x up and down in the y direction. So that means that those things are somehow related, that if you had log of x to base b for any b, then the translations of that graph up and down, they're sort of related to the stretches left and right. Let me show you that on a Desmos calculator. People are putting jokes in chat, which is great. My chat is not quite working. I'm going to need to look over there. Right, cool, good. Here's a graph of what I've been talking about. This is log of ax plus c. And I've got sliders in Desmos here for a and c. Let's make that a little bit bigger. Can I make that bigger? It's not much better, is it? Hang on. Can I make that bigger but still keep... goodness knows. Right, okay. So I can change C, and if I change C, that's changing this plus C on here, which I think is obviously going to move it up and down. So that's not surprising, that translates it up and down. But maybe a little bit surprising, if I change A and kind of stretch parallel to the x-axis, then that also looks like translating it up and down, that somehow the shape of this graph means that squashing it has a sort of similar effect to translating it up and down. So that is the same. That's the same as the fact you already know about how logarithms work, interpreted slightly differently, to say that squashing and stretching it parallel to the x-axis sort of does the same thing as translating it up and down. And the numbers that you use for a and c here are different. They're related via a logarithm. But the family of curves that you get, the set of different curves, is sort of the same as I move either of these sliders. Okay, I just thought that was an interesting fact about log of x, or I suppose the same fact about log of x that you already knew, interpreted through graph transformations. Shout outs in chat. Let's read out this joke that Anonymous has just posted. How do I flag the joke up? A zoo was trying to help in the conservation efforts, conservation efforts of snakes, but couldn't get the snakes to reproduce. Oh, it's a biology joke. They tried in the desert, underwater, and even in the zoo's tanks. But in the end, they could only get the snake children in a picnic area. Why? Because adders can only multiply on a log table. There you go. There's a joke from chat from an anonymous person. If you want to join in with live chat, then you can join in by going to slido.com/matslive, which is where we are. I'm helped in chat today by Flora, who's helping to moderate chat and keep things going. I'll shout out to Tommy and Pehan, and I can see someone with the username Max Verstappen in there as well. And it's broken on my separate. It's broken on my separate monitor. There's a mild complaint about separate monitors there. Goodness knows. Chat's going very quickly. Shout out to Millie as well. Right, cool. Okay, good. Okay. Brill. Okay. Right. Good. We always like to start these episodes with a poll. Here's how the poll works. I give you some options to vote how you feel about the topic that we're going to be talking about today. So today is logarithms and powers. Logarithms and powers. The stuff on the math syllabus just says laws of logarithms and exponentials, solutions of the equation a to the x equals b. Some things for you to think about there. Flora's turned on the poll. Thank you, Flora. Oh, brilliant stuff. Some of you know Flora from Oxford Online Maths Club, topology, and things like that. My word, that's a lot of votes for the sequences and series. What's going on? What is going on? We're voting in the other one. Let's turn on this one. It's a good attempt, but we turned on the wrong poll. I want this one. That's why I have so many votes. There we go. That's more like it. There we go. Sequences and series of previous poll in the system from before. We're getting there. Cool. Logarithms and powers. Let's see if we can break the record, or at least get a record of how we're feeling about things. Molly in chat behind the poll. Molly says, thanks to Flora for recommending Flatland and Flatterland. I'm reading that out because I know those are Flora's books. Someone turned on a poll. I don't know how that happened. Okay, Flora says Flora didn't turn on the poll. I didn't turn on the poll. We've got a ghost going in chat as well, turning on polls. Right, okay, we're getting there. It's going to be one of those live streams. I only noticed it was the wrong poll because the number on the vote was implausibly large. I guess it would add it from previous times. Okay. Flora, it normally doesn't go like this. Yeah, everyone's now saying that was sequences and series. That is the poll on sequences and series. Cool. Right, good. Oh, about time we had some technical issues, isn't it? So we've had about 70 votes in the poll on how you feel about logarithms powers between 1 star and 5 stars. Coming out strongly in the kind of 4-star camp there with an average of about 3.7, which I think makes this as a topic that people like a bit. Good. I wonder what sort of things people are worried about, where people have voted. So whenever this comes back, I'm always thinking about people who have voted kind of 1, 2, 3. If there are particular things you're worried about with logarithms, then we can talk about those as well. Okay. Good, that just ticks down to 3.7 there. Right, cool. Okay, let's try and avoid the ghosts. I definitely didn't turn it on. Flora didn't turn it on. How do we get that going? Cool. Okay. Brilliant stuff. Right, okay. We've got some revision material. I saw a question from someone asking about the best way to use the worksheet material. The worksheets are all available in advance. So if you want to look at the worksheets, you can get them in advance. Have a look at some revision material that we've written to remind you about how logarithms work. By the way, if you're here from GCSE classes or Year 11 or something and you're trying to learn A-level material ahead of time, then hey, here's a quick way to learn everything that the A-level kids know about logarithms. So some facts about logarithms. You could look at those in advance. There's also some warm-up questions. Usually on the stream we talk about some of the warm-up questions, but not all of them. I think it's a good idea to have a look at those ahead of time as well, but it doesn't really matter if you haven't. If you're just joining us now, then thanks for coming along as well. Good. If I hacked into the Slido server, so it's a very worrying question, then mention that in your personal statement. Is that a good experience for computer science at Oxford? Good stuff. Right. Okay. Not good stuff. Please don't hack my Slido during a live stream. How are we doing? Right, okay. I'm going to skip over all the revision stuff and look at the warm-up material. Here is some warm-up material. We've got simplify at the start. So just checking, do you know how to simplify logarithms together? Kind of using that fact that I put on screen for my graphing warm-up thing. This is equal to log base 10 of 12. You're not expected to know what the value of that is, I suppose. Nikita Mazbin in chat wants the fact that log base A... Oh yeah, there's this change of bases fact. I don't think the change of bases fact that's in chat here, I don't think the change of bases fact is on AS level maths. I'm not sure, but I don't think it's a super important logarithm fact. I can work it out anyway. So the fact is, here's the fact. Log base A of x is equal to log base B of x, so using a different base, but then divided by log base B of A. That's a fact. Let's try to prove it. Okay. It's in the AS equation sheet for Edexcel Maths. Okay, so maybe this is the sort of thing that people learn in AS level, and I'm telling you something you already know. Let's try and work out why this is true. So what does this number on the left actually mean? So I think that log base a of x means, I think it means the number, right, let's get this right, the number that you'd have to raise a to get x. So let's say it's the sort of the number c in a to the c equals x. I think that's what this log a x means. It means the number c that satisfies this equation, a to the c equals x. Okay. Let's mess around with that a little bit and think about trying to get it in terms of a base b kind of logarithm. So this kind of fact. This is true. So this is true. This is true for all, I suppose, x, a, and b. Maybe with some restrictions. I probably want x to be positive. I probably want a and b to be positive. I probably want a to not be 1 and b to not be 1, so that these logarithms all make sense. Okay, do I want them to not be equal to each other? No, I think that's fine, because log base a of a is 1, so then the fact is fine and also true. Okay, right. Where was it? Where was I? Right. Okay, my proof was going that log base a of x is the number c that satisfies this equation. I'd quite like a b to appear in here somewhere, so I'm going to write down the true fact that a, this is going to be a bit of a weird fact, is equal to b to the power of something, where d is equal to, now I've got myself into a hole here, I wanted to change the kind of base here, change from a to b. And I kind of know that a is b to the power of something, where d, so the power of logarithms I suppose, d is supposed to be, well, I can use logarithms to work out what that's supposed to be. It's supposed to be this. Okay, with me so far? So I've got the meaning of log base ax, and I've got this kind of true fact that you can swap from a to b like this. In fact, logarithms tell you exactly how to do that. So I'm bringing in these new letters as well to keep track of what I'm talking about. Okay, so I can take this a and put it in here, and I get b to the power of d to the power of c is equal to x. So what does that tell me? That's b to the dc is equal to x by some sort of indices stuff, which means that log base b of x is equal to d times c. Now d times c is just going to be, so I know that d is log base b of a and c is log base b of x. So this is, I think we're now done. Log base b of a times log base a of x, which then rearranges divide through, so long as that's not 0, because a is not 1, divide through, and you get this fact that someone put in chat. Right, good. Okay. What have I missed in chat while I was proving a fact that came in from chat? Do different examples have different content? That's a good question. And there's some shared content in A-level mathematics in UK A-levels. They've now all got a kind of core content for AS levels at least. And I think for A-level mathematics, in further maths it's a bit more complicated, but MAT doesn't use any further maths. And there's a question about practicing MAT type questions. I think Flora has helpfully, B has replied, live stream worksheets. So the things we're looking at on stream, other than past MAT papers, part of the idea of writing all of these like warm-up questions and revision materials to give you something else. I also like other resources that are listed on the MAT website, are things like the STEP support program. The STEP support program came before this. It was built for people learning STEP maths, but has some similar resources, and there's some crossover there as well. Good, right, okay. Georgie wants to know, would any MAT question use this formula or get any easier with it? And I don't think we'd expect you to know this fact. I've had trouble remembering it just now. Because you can prove it in a couple of lines by, if you really want to prove this and work it out, then you can do that. I'm not sure it's a very... I can't immediately think of any questions that we could do with it, to be honest. You can change bases on your logarithms. It's a little bit fiddly. If in doubt, go back to thinking about the powers. That was really the trick. I changed things into thinking about powers. And thinking about powers I'm happy with because I know some sort of laws of powers that I'm all right with. Maybe I could have thought about this with my existing laws of logarithms, but I'm always more comfortable switching back to the kind of underlying facts about powers. Good. Okay. Yeah, would questions get easier with it? I'm not sure. I think so. That's a harder half of the question, because I think some of these questions that I've written in the warm-up just get easier if you know this sort of fact is true. But also there's a kind of grey area that if you've just messed around with logarithms a bit and you've done some stuff with logarithms, then the questions get easier because you're happier moving logarithms around. Let's have a go at some of these, solving these things using logarithms. So in some sense, the solutions are just log base 2 of 3, and then log base 0.5 of 3, and then log base 4 of 3. And those are true. That's a correct set of solutions for this, for solving these. The reason I put them on the warm-up was partly so that you can practice just writing down some logarithms to solve some equations. But I thought maybe you might think about the ways these things are related to each other. So for example, this one, you might think, well, 2, 0.5 and 4 are kind of related to each other. Can I exploit that? Can I do a little bit of algebra to try and exploit what's going on there? So here you can maybe think of this one as 1/2 to the x equals 3. That's a bit like 2 to the minus x equals 3. So then, it looks like minus x is equal to log base 2 of 3. So x is equal to minus log base 2 of 3. That's a little bit interesting. I mean, this thing, let's circle some stuff. This thing, x is minus log base 2 of 3, it is actually equal to log base 0.5 of 3. These are both valid. And maybe if you know loads of facts like this and you're really comfortable with this, then maybe these are sort of obviously true or something. But yeah, because there's a kind of factor of log base 2 of 1/2 hiding downstairs or something. They're not super obviously true. They're not obviously true to me. I think it's interesting playing around with it, like with algebra. Similarly, for this one, you could think about this being 2 to the... You could think of 4 is 2 squared, so you could think of this as 2 squared to the x. I saw someone ask in chat, I don't know if they got an answer. This is 2 to the 2x. Okay. Stuff upstairs. Okay. And I want that to be equal to 3, so now I'm taking the log base 2 of 3, and that's 2 times x. So I'm going to get an extra 1/2. When I'm doing this algebra, I am doing essentially the same thing as this proof in special cases. I always find the special cases easier to work with. Oh, Alejandro says, if you haven't done logs at school, any recommendations to learn it? So I sort of recommend learning logarithms through an official, like with a teacher, rather than off the internet, because learning things off the internet is pretty tricky. If you want to learn logarithms off the internet, then why not download this worksheet and have a look at these facts. I've tried my best to explain what logarithms are. The stuff you've seen so far in the first 20 minutes of this live stream is kind of it. That's just about it. They've got a very nice property that log base a of two numbers multiplied together is the sum of those two logarithms. Otherwise, that's about it. Right, cool. Ooh, changing base. George is looking ahead to see whether we can use this fact that some people know to make questions easier. But it makes it more complicated. Okay, thanks, George. Right. Good. Okay. And Anonymous has asked, what happens if I use a formula that's not in the MAT syllabus? That's fine. Unless you're told to do a question in a particular way, you can use formulas not in the MAT syllabus. MAT syllabus is a little bit vague on questions anyway. Right, okay. We're going to look at a MAT question now. I've got 4 short questions today, and I'm hoping we can get through 3 or 4 of them. And I've got a poll again. I'm going to get the kind of ghost of Slido to turn on a poll for this as well. which then hides chat, but I'll keep reading out chat as that's going on as well. Good, right, cool. Okay, how are we doing? So I'm going to read out the question. This is MAT 2015 question 1H. I can't read numbers. How many distinct solutions does the following equation have? Logarithm base x squared plus 2, all in tiny writing for the base. There we go, a little bit better. Open bracket 4 minus 5x squared minus 6x cubed, close bracket, is equal to 2. What does that mean for the value of x? And people in chat are voting at the moment. The first people to vote think that this has maybe got 2 distinct solutions. Let's think a little bit about what distinct solutions means here. I suppose distinct solutions would be different values of x that work in this equation. You might have seen something like this. For a quadratic, they're called sort of separate roots. For more complicated equations, we might talk about solutions. Ooh, here's some good. So people are putting their algebra in chat. I like seeing the algebra in chat. Millie, that's a great question. I like that. There's a suggestion in chat from an anonymous person that this whole live stream might be a sponsor ad for Slido, which would be, given that I just said that their software is haunted, I'm not sure it's a very... Is that an advert? And, ooh, but natural log of both sides using base 2 or 0.5. Username pi. Yes. I think that's equivalent. Username pi. So if you take logarithm, when you see an equation like a to the x equals b, you could take logarithms base a. That makes your life nice and easy. Or you could take logarithms base something else, like e or pi. Makes your life a little bit more complicated. You can then do some laws of logarithms on that. Maybe that's a quicker way to prove the thing I was trying to prove. Now that I think about it. Okay. Right, good. Okay. Let's try and solve this question with help from chat. I'm going to have a look at what people are saying in chat now. Okay, so there is a quartic equation. So despite all of this, a fourth order polynomial, degree 4 polynomial. Yeah, aha. So and somebody's put down a polynomial. And I like this suggestion. Turn back into an exponential and reverse the definition. George says. Zach wants to re-express the logarithm. So yeah, I think we're getting there. Yep, I'm good with what B says as well. Yep, so maybe disappointingly for our first logarithm question, I think the right first step on this question is to get rid of the logarithm. You know, we see a logarithm. I love logarithms. They're one of my favourite things. But I think the right thing to do here is x squared plus 2 to the power of each side, which is a crazy thing to do in a question. That's never been the right thing to do in any question I've seen before. It's probably never going to be the right thing to do in any question I see in the future, but I really think that x squared plus 2 to the power of each side has got real potential to work out here. If you try this on general equations that you've been given, then normally just descends into madness. But here, because of the definition of logarithm based anything means this thing. This thing is what you get. Oh god, what you have upstairs in the exponent to get the number outside. I've said that really badly. Let's try one more time. X squared plus 2 to the power of this logarithm is going to be exactly the thing inside the brackets. So that's pretty nice. The right hand side gets much worse than it was before. It becomes x squared plus 2 to the power of 2. There we go. And then we can rearrange that, I think. And things are going to be okay because I'm going to get a 4 on both sides when I multiply out this square. Oh, right, good. Okay. So we get 0 is x to the 4. What do I get? What do I have here? Plus 6x cubed. And then I've got plus 9x squared. Talking not good today. Talking not good. But chat's doing very well. So this is good. Okay. I can factorise that. I can bring out a factor of x squared, and then I get 6x plus 9. And I'm going to try and factorise that inside. Few questions in chat. Do you need to show all your working to get the marks? No, not for the multiple choice questions. For the multiple choice questions on MAT, you get all the marks if you get the right answer. You don't need to show your working out. You're encouraged to write your working out so that we can see what you were thinking during the question, but you don't get marks for the working out here. This quadratic, I think, factorises. I think I recognise this. We'd like to know from chat actually how do you know this factorises? I can think of several approaches. Maybe you throw the quadratic formula at it. Get out your quadratic formula, like, aha, quadratic, let's go, quadratic formula. And try and write down some roots. Or you might try and factorise it, try and write down some factors. Or you might, difference of two squares, says someone in chat. Oh, two people, no, one person, twice. Difference of two squares, interesting. You might have seen it before. or completing the square. I like completing the square as well, as approaches to spotting that actually this thing here is x plus 3 squared. I wonder what your two squares are if you want to do difference of two squares on that. Because it is a square. So okay, right, good. Either way, turns out that this has got two solutions, x equals 0 or x equals minus 3. So give yourself a round of applause if you picked C, two distinct solutions. It's quite nice that it turns out to have quite nice that it turns out to have some repeated roots. Gives it a little bit of texture as you're solving the polynomial. It could have just been a random polynomial. It's been chosen to be a little bit like a nice polynomial. Okay, good, right, cool. I think chat did well on that one. I wasn't really paying attention to the vote, but I think chat did pretty well. Okay, and there's a bit of discussion in chat about whether that's two solutions or three. I think because it's possible to get to this line and think, aha, x is 0 or some quadratic, and then solving quadratics is usually tricky and work, so maybe that's two roots. Turns out that quadratic's got a repeated root. There's another step that we should probably go back and substitute numbers back in. There's some question in chat. I can see somebody worried about can we actually plug in minus 3? And you can, because the base of the logarithm here is still a positive number. The base of the logarithm is always supposed to be a positive number, and it is. It's 11. So what we've discovered, I think, is the strange fact that log base 11 of 4 minus, so when I put in minus 3 here, I get minus 45. And then over here, I get 27 times 6 is 108, I think. Do I mean 108? No, 27 times 6 is 100 and much more, 120 something, 162. Yeah, that looks more likely, doesn't it? Because then this is 166, take away 42 is 121, which is true. So somehow this combination of strange numbers just works out to be some true fact. So x is minus 3 really does work. X is 0 also works. It's just sort of a good idea to go back and check your answers, isn't it? That one's easier to check. That one's just true. Yeah, so people are telling me that we can't have a negative logarithm base, but I don't have a negative logarithm base. I have 11, which is a positive number, as my logarithm base. So that's all right. There's a really weird logarithm base, x squared plus 2. So even though the number we're putting in is negative, we're okay, because x squared plus 2 is fine. So minus 3 really does work in this equation. Is it minus 162? I've got 4 minus signs, 1 out the front, and then 3 from this cube. So I think it's plus 162. Good, right, cool. And because it's chat, we're trying to use logarithms to prove Castellan's conjecture or something. Cool, right, good. Okay, fun, right. Good work on that logarithm question. I like the structure of the way when we solve this question. It starts off looking absolutely impossible. It's a real uphill struggle to think of anything we could do, but then once we get rid of the logarithms, now it's turned into a polynomial question, and we know loads of methods for solving polynomial equations, or just working with polynomial equations, especially nice ones like this, where we can pull out some factors and factorise some quadratics and stuff like this. So the question starts, I think, quite stressful. We don't know what we're doing, we've got some weird logarithms around, but then it ends up being a bit more relaxing once we get down to the polynomials. For me, anyway. Right, cool. Let's have a look at another one. This one's a bit complicated, but it again combines together logarithms with equations. I'm going to turn the poll on in a moment. We're going to think about it first. We are told, that was worth 4 marks, by the way. 4 marks towards our MAT side of 100, so that was 4% of a MAT right there. Cool. 4 marks for correct answer, no marks for wrong answers on the multiple choice. Okay, cool. Hi, Sam. And there's the classic MAT Livestream question, can we put complex numbers in here? The answer is yes, logarithms of complex numbers are really good fun. They're brilliant. They do loads of really interesting things that I can't talk about today because MAT doesn't have any complex numbers. Good, right, okay. Look at this question. This question is really complicated. This is 2017 question 1I. The multiple choice questions are often sorted a little bit so that the first ones are a bit more approachable and then the last ones are a bit more scary. This one looks completely crazy. It's got lots of brackets going on and lots of logarithms. Look at all these logarithms. Different bases on as well, I've just noticed. There's a base B logarithm here and there's some base A logarithms over here as well. So I think before I've even read out the question, I want to try simplifying these things. I want to simplify what on earth's going on here. I can see, I suppose, when I start to read this, that this is log base B of something involving powers of B. So I'm sort of hoping that that simplifies somehow. I might need to do some laws of powers on the inside. Aha! Chat's already thinking about what that might simplify down to. The question itself asks about repeated roots. I can already see a good b squared equals 4ac, which that's a repeated root for a quadratic. You know, so maybe there's a root there. Maybe the structure of the question is it's secretly a quadratic. I mean, it's just b squared equals 4ac. That's repeated roots of quadratics. Option A. Amazing. That would be one route through the question. I don't know if that's going to work out or not because I haven't done the algebra yet. Good. Okay. Yeah, people want to simplify this. Loki's called that a hidden quadratic, you know, which is almost appropriate, a sort of secret hidden thing that we're going to try and discover. I suppose people have spotted that this first term has got 2 x's in. This middle term has got sort of x only appears in the power once, and this one's got no x's in. So it's kind of feeling that maybe that doesn't quite feel like a quadratic, but it's a quadratic-ish, I suppose. I suppose this thing I could write as, you can bring out the power. I suppose that's a bit like the addition rule, that this is log base A of c over b to the power of x inside. So I can bring out that x and write this middle term as this, x times log base A c over b, which is some number. And this thing over here, log base A 1 over b, log base A c, fine, whatever. Okay, not got any x's in. Maybe this is. Aha! We are looking for a, yeah, so maybe it's the language of repeated root that clued some people in to start looking for quadratics. I think it's one of the options being b squared equals 4ac, that maybe that's not a healthy way to think about questions, but for me, that was when I started thinking about quadratics. Okay, let's try and simplify this first one. I saw some people telling me that this is just going to turn out to be x squared. If this is x squared, then we're, I mean, basically done, right? Because if that's x squared, then we've got a quadratic. We're great at quadratics. Okay, so what is this? So law of powers means I could write this as x log base b of b to the x, where I've kind of ignored the fact that's a b to the x inside, and just used the fact that it's, well, it's something to the power of x, so I'm going to bring out the x. But then I can do that again, can't I? I can bring out the x again to just get x squared log base b of b. Aha, now I'm really excited because log base b of b is 1. Brilliant. So that's just x squared as the first term. It is x squared. Amazing. Yep, so I've brought down both x's in the first term. Good. Somebody's asked, how does x times log c over b work? And it is just the rule, the thing inside is c over b to the power of x. Cool. Okay, this looks like it's turning into a quadratic. I'm going to let chat get involved. Let's turn on a poll. Yeah, there's a question. How do we expand that last one? What's going on with that last term? That's sort of a bit like a quadratic, but maybe not quite. Let's have a vote going. I'm going to hide the results as well to make it more exciting. So the final question is going to be, when does this have a repeated root? I'm going to write out what we've got so far. We've got x squared, that first time simplified loads, plus x times log base a of c over b, plus, and then we haven't done anything with this term yet, equals 0. And the idea that we've had, I suppose, we've done two things. We've done some algebra and had an idea. The algebra has given us this, and the idea is that this looks a bit like a quadratic where these are the coefficients. Okay. People are voting on what they think the answer is going to turn out to be. At this point, b squared equals 4ac is looking a bit less likely, I suppose. If it had turned out to be ax squared plus bx plus c, then I'd be off and away, this would be perfect. We've got some options on this quadratic. I suppose I could be really, really careful and write down the rule, write down the discriminant of this quadratic to find out what's going on there. And there's some suggestions in chat. Yeah, so Simon Singh, the person with the username Simon Singh, wants to use the discriminant. If you're using the discriminant, remember to be really careful that this thing I've underlined in the middle is b, and this thing over here is c, even though this question already uses the letters b and c. Okay. And Pi would like to rearrange this thing over here to minus log base a of b. I can't see anything wrong with that. In fact, I might rearrange this coefficient as well. We've got the option of doing this, haven't we? We could write this middle one as log base a of c minus log base a of b. Maybe this would have been a good first step to sort out the fraction first, and then take the x out of each one of them, and then bring the x's out the front of this bracket. I don't know. Up to you what sequence you do steps in, I suppose. So there's some suggestions on rewriting these terms. Looking good. Yeah, how do you square a logarithm? Well, you just square the logarithm, right? You just write it down, put brackets around it, put a little 2. I would work with that. So if I wanted to do the discriminant, I'd write down something like this thing squared minus 4 times the product of 1 and this thing at the bottom. I'm reluctant to do that because I think it's looking quite complicated. And things are a little bit more simple than that. Okay, we've got some votes in chat, and also we've got some suggestions. Yes, I've made people type so many logarithm facts. If you've been typing logarithm facts, somebody at the start, before we went live, said that they were watching this on a train. If you're watching this on a train and I'm forcing you to type loads of logarithms in, then thanks for joining in. Look at all these logarithms in chat. Good. Right, cool. In fact, let's turn off this briefly so that people can see. People are typing all these logarithms in chat. Look. Right, you're on the stream. Cool. But people were maybe voting, so I'm going to turn that. No, okay, right, good. Okay. And somebody says this is the first MAT MCQ they ever got correct, which is nice. Okay, cool. Right, what do we want? I like the suggestion that I did see in chat. I forgot who said it first. But you can factorise this quadratic. I don't feel like I do a lot of factorising, so I'm going to try and do some now. I suppose the person maybe spotted that these things here, log base AB, log base AC, are the same objects that appear here. Log base AC, log base AB, and there's even a minus sign. So this looks like it factorises the quadratic to x, what do I want, minus log base AB, x plus log base AC. I think that works out. Yeah, I think that works. Okay, so maybe if you expanded these things, rearranged them a little bit, you'd spot that they had the same objects in, and those objects are more or less the roots of the quadratic. Okay, so we've got some roots. So maybe I could talk about the discriminant of the quadratic, or maybe I could just talk about the roots. It's sort of remarkable that we started at this equation at the top here, and just by simplifying things, just by simplifying things down, we've got it into this form at the bottom of the screen, where we kind of just know what the roots are of this equation. We know what the solutions are. There are two solutions. One of them is log base AB, and one of them is minus log base AC. So I suppose that just means that it's a repeated root. I suppose if log base A of B is equal to minus log base A of C. Okay, which means, so this thing, log base A of B equals minus log base A of C, that just means B is equal to 1 over C. Pretty good. Okay. Amazing stuff. Right, cool. I think B is 1 over C is the same thing as C is 1 over B, which is option D. And if you did, so if someone in chat says, if you didn't spot that, and if you didn't spot that, then I would go for the discriminant. We've got it down to a quadratic, and we want to know whether this quadratic has a repeated root. It has a repeated root if and only if the discriminant is 0. Where am I going to write the discriminant? I'm going to write the discriminant, this is awkward, but I'm going to write the discriminant here. So my discriminant is log base A of C over B squared minus 4 times AC. Now this rearranges a little bit to be log base A C over B squared is equal to 4 times log base A 1 over B log base AC. From there, try and, I think we're going to need to recognise that, well, I'm going to multiply out my square, I think. I think I'm going to write log base A of C minus log base A of B. I think I do need to split that up like that. And then my right hand side is still 4 log base A 1 over B log base A of C. And I'm now doing pretty much the same algebra that I did down here. This multiply out the square, bring in the 4, flip the minus sign using the logarithm, and then factorize it again, and you get down to this fact over here. So you can do the algebra from the discriminant if you don't want to factorize the quadratic, but it does just turn out to be the same algebra. Right, cool. There's sort of a quadratic going on over here in the logarithms. Good. Right. Okay. Tried each of the options and D worked. Oh my word! How do you try the options in this? So you try C as 1 over B, and then try and solve the equation and check that it's got repeated roots. Sounds complicated. I just want to check how did chat do on that one. We have fewer votes and massive success, like 73%. Good stuff, chat. Right, good. Okay. Brill. I like having this pair of questions in on the worksheet, partly because they have a similar kind of feel, that both of them involve logarithms, but kind of our mission is to get rid of the logarithms, or to use any logarithm facts we can think of while working with them like polynomial equations. Of course, in the real world, there are logarithm questions that don't involve polynomials, but somehow both of these ones turn into polynomial questions. Right. Another one? Yes. Okay, so anonymous person here did the discriminant, big D is equal to B squared minus 4AC. And George used the fact, arrived at the fact that log base A of C times B is equal to 0, which is the same thing, and CB has to be 1. Okay, cool. Have I missed anything important? You can see straight away the value of A has no influence on the values of B and C. So it has to be the option without A. Ooh. Seems to be a bit... that's quite a deep observation, isn't it? We see straight away that the value of A has no influence on B and C, but it's in all these logarithms. Maybe I'm being slow, but I feel like changing A changes. If I change A, then I'll change. It does change what the solutions are, so it feels like it's not obvious that it should be independent of A. It changes the solutions, so it happens to change both of them, so that they stay the same when you change A. I have that in the not obvious category. Right, cool, one more. What are we doing? Oh, this one's quite complicated. Do I want another polynomial one? Yes, I do. Right, cool. Okay, this one causes a lot of trouble. I'm going to put it in the live stream anyway. Here we are. We're live. We're doing this question. It's pretty tricky. Here's the question from SV. Can we put matrices in logarithms? no, but this logarithm question feels like the same idea of sort of multiple choice things. Molly likes that question, which I like to see, because I thought I made a mess of doing that question on the live stream. If you did that question at home and got the right answer, maybe even with less work or less stress throughout, then well done. Give yourself a small round of applause. Right. So, new thing I'm trying out. Small round of applause. Yeah, how did I simplify? So there was a last step. Somebody would like clarification? Simplifying the last step of those logarithms. I guess I did a to the power of both sides. And I like moving the minus sign inside or outside. That particular rule, the one that says minus log base a of b is equal to log base a of 1 over b. I've used that fact so much that I can kind of just flip-flop. When I got it down to thing equals minus logarithm, I was already kind of imagining bring the minus sign inside and flip that thing over. And then log base a of two different things being equal means that those things are equal. Right, cool. Algebra in hand symbols for algebra. Very tricky. Right, cool. Okay. Let's do some of this question. Ooh, is that a good idea? Let's do some of this question and talk about the options. I've done this question with people in person before, and it's usually turned into a chat about what it means to specify a uniquely. The options here are word phrases that are a little bit unlike stuff you might have seen elsewhere. Okay, so the first step for doing this question, I think, is to use the definition of logarithms to get rid of all the logarithms, which is maybe disappointing that that's what we did for the other question as well, which is get rid of all the logarithms, to turn this into a system of equations that looks like a is b squared. I'm doing b to the power of each side. Over here, I guess I'm going to do b to the power of each side again. And over here, I'm going to do a to the power of each side to get rid of that logarithm. And now we've got a system of equations. They're not nice linear equations. Well, they're quite nice equations, I suppose. These two involve c. We could get rid of the c by looking at the difference between two of them. But I guess rather than jumping in and doing all the algebra, I'd like to talk a little bit about what the options mean. It's sort of asking a similar thing to the other questions. The other ones were asking about how many solutions there were. We had options like there are two solutions to this equation, or aha, I know when there's a repeated solution to this equation. Here we're sort of asking about how many solutions there are, but there are cases in there for whether the answer is infinitely many, 0, or 1, or 2. Possibly you could rephrase this question so that the options are 0, 1, 2, or infinitely many. But in order, let's look through. So specifies a uniquely would be true. That would be the case if this system of three equations turns out to have exactly one solution for what the number a is, a sort of unique solution for that. And the next one is, I think, easier to understand, or maybe satisfied by infinitely many values of a, would be if there's a system of these equations where you could have a being lots of different things and still make it work with b and c, satisfying all the equations. The last one is contradictory, would mean there are no solutions for a, b, and c. It's a little bit complicated because we've got a and b and c going on. People in chat are telling us how to solve these equations, which is brilliant. Yep, Zach is saying eliminate. Yep. Oh, Zach's already solved through for a is 4 and c is 11. Anonymous person wants to make c equals stuff in equations 2 and 3. I like that. It's b cubed plus 3 and a squared minus 5. Make them equal to each other. So this is pretty good. You get a b cubed minus 3 is equal to a squared minus 5. I like that. It's got no c's in it. I also know that a is equal to b squared. I'm going to bring that in at some point. Should we turn a poll on? Yeah, let's turn a poll on. Good idea, B. Where are we? We are here. There we go. People have got some solutions. I'm going to keep working through, I think. I know that a is b squared, so this is looking like a b to the 4. I should definitely check my solutions when I get, ooh, I'm not happy with this, I want a plus, I want a plus. So anyone told me to fix the plus? Oh, I think I got away with it. Normally chat's very quick at pointing out mistakes that I make. In before, I'm going to put an 8 over here, I think. b4, b to the 4 minus b cubed should be equal to 8. It's a pretty tricky equation. Not sure I can solve that one. Good. Okay, people are voting away, trying to work out how many solutions there are to this equation. It's a bit of a nasty equation. So I've eliminated c and a. I've got down to this equation with some b's in. I can factorise this bit. I don't really want to factorise it with the 8 in there as well. I guess I'm thinking about this being b cubed times b minus 1. And then I want that to be equal to 8. I suppose does 2 work? So 8 is 2 cubed. And this looks like something cubed times b minus 1. So I think b equals 2 works. But I'm a little bit worried that there might be something else. I actually spotted that 2 cubed in here sort of works out nicely. Someone in chat has asked about complex numbers. They are positive, which implies that they're real. Also, there's no complex numbers on that. Okay, cool. Spotted that 2. Yes, people want me to try b equals 2. Factor out the b cubes. Cool. Sure. Good. Okay. They are positive numbers. They're not positive integers necessarily. They're not positive whole numbers necessarily. B, I think it's turned out to be maybe number 2, maybe something else. We should think carefully about this. Sure. So one way to think about how many solutions this equation has would be to just solve it. Find all of the solutions, write them all down, and then check how many there are. Another way, perhaps a more useful suggestion, might be to try and think about the graph of this right-hand side. To think about, as I change b is supposed to be a positive number, what does that graph look like? So that would look like b cubed, so minus b cubed would be something like this, but then plus b to the 4 would be something like this. I think it would end up looking a bit like that for b. I guess this is b on this axis. So we go down to start off with and then up. I think kind of also because its roots are 0 and 1. We'll factorise this a little bit. So I think after 2, graph is not to scale. After 2, I think it probably doesn't have any more solutions because it's an increasing function after here, isn't it? It keeps going up because after 1, b minus 1 gets bigger and bigger, and also b cubed gets bigger. It's an increasing function. Good. Okay. Sam, I agree. Yeah, sketch this graph, look for change of signs, or just look for the kind of general shape. How many solutions does this thing have? Once it gets past this point, I think it's just going to keep increasing. Because after here, it's b cubed times b minus 1, and those things are both increasing. Okay, so I think nothing else. I think just b equals 2. What does that mean? That means a is 4 from the first equation, and then from the other equations, c is 4 squared take away 5 is 11. I think I've got a unique solution. Yeah, for another intersection after 2, George in chat says we would need another turning point. We'd need something else to happen over there. And it hasn't happened. I think it just keeps increasing and we just get that solution. We're in a kind of weird abstract space around here, a kind of abstract dimension where we're thinking about b on the axis, thinking about what happens as we change b. You don't have to think about this as stuff equals 8 for finding solutions. You could move the 8 onto the right hand side and think about that polynomial and think about how many solutions it's got. Think about what happens after you get one solution. So you can think about it like that. Anyway, it turns out that it's perhaps one of the easiest answers to understand, which is that it specifies a uniquely, which is pretty nice. Chat was so across this one, 84%. Look at that. Good job, chat. Right, good. Okay, cool. Yeah, okay. In a race between an inverse log graph and an inverse exponential, which one wins? So I think an inverse log graph is an exponential. They famously grow very large, very fast. And an inverse exponential is a logarithm, which grows very slowly. I think this question is the inverse log graph. Cool, right, good. Yeah, how do you know how many turning points there are? I suppose if you're thinking about turning points, you've got to think about how many turning points there are. I like this argument of thinking about how after here, I know that these things, thing inside the brackets b minus 1 and thing outside here are both increasing functions. I didn't consider the graph in the negative axis because I've been told that the numbers are positive. So I did not think about what would happen if b was negative. Okay, right, cool. Let's put the last one on the screen just as we get up to 6 o'clock. It's pretty tough. It's a JA question. It's from, I think, the same year as the previous one. George says you could differentiate the previous one. You could differentiate the previous one to find its turning points. Yeah, you could do a really good job of sketching that curve. Cool, right, okay. I'm moving on to J. Just put it on the screen. Yeah, the time has flown by for this one. That was almost an hour of your life. I said that like a bad thing. So I'll put this one on the screen. We'll talk about it a little bit. I think it's probably time for me to take some of your questions at some point. Right, cool, good. Okay, this question's tough. I think even if we don't finish doing it, we can think about what's going on. So, the question defines the floor function. Let's quickly. It doesn't call it the floor function because you don't need to know that it's called the floor function, but it's called the floor function. It takes your integer. It takes your number and it drops it on the floor. It reduces it to the largest integer that's less than or equal to x. And today we're only plugging in positive numbers, so none of this. You don't have to worry about what goes on with negative numbers, but fine. Okay. It is in fact defined by real numbers. You might also be interested in its cousin, the ceiling function, which rounds numbers up. Okay. We are asked to do an integral, and it's not one of the functions that we know how to integrate. It is open square brackets 2 to the x, close square bracket. We're asked to integrate this. And we're asked to integrate it from 0 up to n, which is a slightly strange choice of number. And we're told that n is a natural number, which I think means a whole number that's positive. Maybe 0, maybe not. Doesn't really matter. If n is 0, this thing's 0, so not super exciting. Okay. So this question is quite tricky. I think we've got to work out what the function inside the integral looks like, and then rather than integrating it with some sort of rule, we know a rule for integrating things like polynomials. Add 1 to the power, divide by the new power. Rather than integrating it with a rule, I think we're going to need to think about areas instead. Think about what this function looks like, what that area is. This turns out to be quite tricky to do, even once you've thought about thinking about the area, so I think I won't spoil all of the algebra. There's quite a tricky calculation going on to work out what the thing looks like. It's sort of a graph sketching question. Nowhere in the question does it say you should sketch this graph, but you should sketch this graph. You should try and draw that function inside, which is, let's be clear, take the 2 to the x graph that you know how to sketch, but just show me at each point the largest integer that's less than or equal to x. That's harder than you might think. Cool. Yeah, so it looks like stairs because it's going to return whole numbers. It has to. It rounds things down, so it's going to return whole numbers. It's going to look like stairs, but thinking about the width of the stairs and the height of the stairs is slightly tricky. Okay. Yeah, do not do integration by substitution on this one. It's not helpful. Also, you do not need to know what integration by substitution is for the maths. It's not on the syllabus. I think we've got integration week next week. Cool. Okay. So yeah, splitting this integral up into lots of bits. I think once you've realised it looks a bit like stairs, having different contributions underneath each of the stairs. I mean, if it looks like this, then that would be great because we could just write down the area as sort of this rectangle plus this rectangle plus this rectangle. It would be great. This is like a carpentry sort of bit of the live stream. If you've got stairs, then you can work out what the area is underneath the cupboard under the stairs by just adding up lots of rectangles. Here we've got a bit of a tricky problem because we've got to work out how wide the stairs are and how tall the stairs are. Where are the stairs? Once you've worked out where's the stairs, then adding up some rectangles is the next bit of the challenge. Lots of logarithm work to simplify it down. It's actually a really nice question in a way that it tests lots of stuff. And it's multiple choice, so you definitely know if you get to the right answer. Okay, but I'm going to leave that, and then there is some sort of adding to do. Oh goodness, do you get some sort of series? I think you get lots of logarithms to add together, and the whole thing collapses down nicely into one neat logarithm, possibly. Or maybe some geometric series stuff going on. No spoilers. Right, cool. Okay, I'm going to leave that one on the screen because I think people are thinking about it, but I'm aware that we've made it up to 6 o'clock. Thanks for joining us. This is happening every Thursday between now and the actual MAT test this year in 2021. We're going to cover the rest of the MAT syllabus, and we've got a back catalogue of 4 other episodes already covering some other bits of the syllabus. If you grab the worksheet, then you can find the rest of the questions, including the warm-up bit that we sort of skipped, and including some extension material, which is nothing to do with the maths, but it's just sort of more facts about logarithms this week. You can also get the worked solutions the day after the live stream. So we do other stuff in the solutions, going through what I was thinking about when I solved the questions. Coming back. Okay. There's a really good stairs joke that somebody said they recognised the question from Step, or something like this from Step, and that it's got stairs in. There's a really good joke in there that Ali got that I missed. Good. Is the width the same for all of them? It would be for... That's a good step construction idea. In fact, Sam, it's the stairs are actually different widths, so it's slightly awkward. Cool. One person says, we got it, but it's C. Right, cool. C was previous question. Right, good. Okay. Yeah, Jonathan, I agree. The width gets smaller, but the height stays the same. Height's always 1. Oh, thank you, Flora. Flora's flagged a question for me. Do I grade personal statements numerically when considering them in an application? We do not. We don't give your personal statement a number. Cool. We do read your personal statement. We look at it for useful information, but we don't give it a score or a number. Cool, right, okay, this is new and exciting. Let me have a quick look at what else has been going on in chat. I'll take this one. Is it possible to get into Oxford for CS if you aren't good at maths, but very good at computer science? So that's tricky because I'm not quite sure how you can be very good at CS without being a little bit good at maths. CS uses the maths admissions test as well. In particular, you have to do all the multiple choice questions, all 10 of them. Those are questions that you should do if you're applying for computer science. You do need some math skills. So I suppose my answer is, I think I'm leaning towards no. I think you need to be good at maths to do computer science at Oxford. I'm not the computer science admissions person though, so if you want to talk to them, then either check the computer science website, search for computer science Oxford or something like that, or ask them at the open day next week. We're doing another virtual open day on Friday the 17th of September, where you can ask anyone anything about admissions for Oxford undergraduate courses. If you search for something like virtual open day Oxford, that's on Friday the 17th. I think we're running stuff all through the day with different colleges, answering questions and chatting to people, lots of students and departments as well. I'm going to be doing some sort of math workshop thing on the day next Friday, but we'll see. Okay, cool. I'm just typing to Flora, who I'm aware, I told Flora this was 1 hour and we've overrun, so thank you, Flora. Cool. Here's a great question. If we prove the Riemann hypothesis accidentally, so I love the narrative that's going on in this question already. So you've proved the Riemann hypothesis, and you weren't trying, it was an accident. And then the question, because this is my live stream, the question is, can I put that in my personal statement? Which is lovely, to bring it back to what can I or can't I put in a personal statement? Yeah, you can tell us about that in your personal statements. That's like quite a good story. Right, cool. Ankit says, I understand why it's easy to switch between BSc and M-Math in the first few years. Is there any point applying for the M-Math now itself? In what situation would someone want to do that? I'm going to flag that up to the top. I recommend, so I'm not great at financial advice. You should not take my financial advice very seriously. But I think that if you're a UK student applying for student finance, then I've heard anecdotally that if you apply for the M-Math course and you tell the student finance people that you're doing an M-Math course, then it's easier to switch the funding to have 3 years of funding instead of 4, rather than the other way around. The other way around, you've got to tell them that you're doing an extra year. Whereas, anyway, I'm not sure how relevant that financial advice was. That was advice that was maybe more useful 10 years ago. But in practice, you don't actually get the choice. I think everyone just applies for the same thing, which I think is the M-Math course. Anyway, right, cool. Long rambling answers to admissions questions. If that's what you're interested in, hang around because I've got more of this. Good. Can I talk about? Oh, let's have that one. Can I talk about maths YouTube videos I've watched in my personal statement? I saw it in there. Yes, you can if you like. Tell us what you got out of them as well. Tell us what you enjoyed about watching the video, and if you thought more about it after watching the YouTube video, then tell us about any investigation you did, or further reading, or more exploring you did. Anyone can watch a YouTube video. Make it a little bit personal. You actually get a number of how many people watch the YouTube video, so try and make it like a personal angle on that as well. I would recommend. Michael would like to know if I do any interviews, and I have done interviews. Let's go in the past tense. I have done interviews before. I'm going to do a live stream about interview questions in approximately 2 months or something. When we get closer to interviews, I'll do a live stream talking about interview questions I've used. There are other people on YouTube who are talking about maths interview questions. I think some of my interview questions are out on the internet. If you dig hard enough, you can find me talking about interview questions. But I'm going to do that again in a couple of months on this show. Right, cool. Is it possible to get in if you have no significant supercurriculars? So supercurricular means doing things outside of the classroom, like going to extra classes or trying extra bits of mathematics or thinking about tricky maths problems, even though it's not part of your school curriculum. Arguably, and it's debatable, but arguably this is one of those. So sort of if you're doing the Matt live stream, that's already a little bit supercurricular of you. If you don't do any maths outside the classroom, then I think you could still be good at maths. It's just a little bit more unlikely, isn't it? But if you're really keen on mathematics, you've probably seen some outside of the classroom as well. Probably found out about some more stuff. Okay, right, I'm going to verify this method. What is this? Warm-up problem. 1 to the x equals 3, which I think has no real solutions. So they've written x is log 1 equals log 3. X is log 3 over log 1, but 1 is, and then complex numbers, because people love putting complex numbers on the Matt live stream. Yeah, so this doesn't work because complex numbers there's not a unique argument for your complex number. Yeah, so I'm not having this. Well, they have put a k in. Do I like it because they put a k in? Yeah, I think I'll allow it. I think it looks okay to me if you use complex numbers as well. Okay, but here's a complex number thing, which is anyway. Okay, what have I missed? Really nice question on combinations. How many ways can you select letters from the word physics? Selecting at least one letter. It's fun. Try it. Okay, right. Select. How many words? Do I have to make a word? No, just select letters. So 6. 7 maybe? Okay, right, good. How many ways can you select letters, plural? Selecting at least one. So maybe if I'm not allowed to select no letters. Okay, right, good. I don't quite get it. Is it 2 to the 6, 2 to the 7? Not quite sure. Cool, right, good. Supercurricular, change at the start of your second year of maths and stats. Yes, we can't promise in advance. We can't promise in advance that you can swap courses. In practice, some people do, but it's always in discussion with their college and the tutors at their college whether they can swap onto the maths and stats course. It depends a little bit on teaching in the college as well. Good. Right. Do you learn about maths in real applications? For example, Euler's identity in impedance in a circuit. In a maths degree, there's a little bit of that in a maths degree, not all the way through. So when you learn about Euler's identity, that might or might not mention impedance in a circuit. Probably wouldn't, to be honest. We tend to have sort of separate courses on things like electromagnetism or dynamics, taking maths facts that you've learned from other courses and some new maths facts, and using those to explain things like things in the real world. So there are application courses in there as well. Cool. The interview question is, Flora's on it, around 3 or 4 days. We do 3 or 4 days of interviews, each person getting interviewed at least once or twice on average, really. At least once for about 20 to 30 minutes, which Flora's typed in there as well. Flora's still here. Hi, Flora. Cool. Do you choose what college to apply for, or are you assigned to one? Asks Adam. And the answer is slightly complicated. You can do either. You can choose one college to apply to if you want to, or if you don't care which college you want to apply to, you can make something called an open application. If you do an open application, then you get assigned to a college and treated exactly as if you applied to that college. So you can have one choice if you like. I forgot to read out Aris's excellent joke from earlier, but it's a little bit too late now because it's about an hour ago, but it's a very good joke. I just saw it again. Cool, right. Another question about MMath. So the way the chatting section goes is I get behind and then I start answering questions from about 10-20 minutes ago, and we get into this kind of feedback loop of different topics, but then after 10 or 20 minutes the kind of follow-up questions come through. So here's a follow-up question about MMaths. Do you remember that from 10-20 minutes ago? So it's the first 3 years of MMath is the same as the BSc. Yeah, exactly the same. Yeah, that's how it works. It's just a case of staying for the 4th year. Why do we not have an undergraduate applied maths degree? Well, we sort of do. We have some applied maths in our maths degree. So you can take applied options through 2nd and 3rd year. We think it's important to learn kind of maths in 1st year that you could use for applications or you could use for understanding pure mathematics, fundamental mathematics either. Okay. So yeah, okay. We sort of do just call it mathematics and hide it by having optional courses. Oh look, it's the opposite of the question from before. Do you remember the question before? Can I mention how I tried to find a counterexample to the Riemann hypothesis by putting it on Python? Right, cool. Sure. Tell us about stuff that you've been up to, whether or not you've proved the Riemann hypothesis. Oh, hi, Riley. How are interviews allocated? That's a good question. Let's flag that one up. So interviews are arranged by the colleges that are interviewing you. So the first college that's interviewing you chooses some interviewers. Those might be lecturers or tutors or teaching staff at the college, or they might be graduate students who've had some training, or sometimes a combination. Usually, I suppose, some sort of combination of a graduate student and a tutor, or maybe 2 tutors. But they're chosen by the college that usually work together with other interviewers from that college to think about the questions that they're going to ask and interview people assigned from the pool of people who they've shortlisted for that college. And similarly with the people they're interviewing as second college candidates. Right, cool. I went into slightly too much detail there, which is normal for this stream. Classic question. Is it okay that my personal statement isn't very special? Just talking about aspects of maths I like and related research. That's pretty normal to me. Oxford's lucky Let's do this chat again. Oxford's lucky we've got the maths admissions test, and if we shortlist you, we've got interviews as well. So we've got those things to help us tell applicants apart, which is really helpful. If you're really good at maths, then you do maths questions like this one, and we get to see that, which means we're not relying quite so much on personal statements. Other universities might rely more on personal statements, I'm not sure. Okay, good. If you hate statistics, asks a goat, can you still do a maths degree? And sure, there's some probability in statistics in a maths degree. It's kind of taught differently from A-level mathematics. Some people find out that they like maths and they like statistics after all, even if they didn't like it at A-level, but then started seeing some of it at university. There was a question about IMO problems there. If I do practice IMO problems, is that good skills for prep for MAT? I think it could be. I think IMO problems are a little bit different. They sometimes involve knowing a lot more facts than you would know, than we assume for the MAT anyway. Especially lots more geometry. Will's got an amazing powers of x sort of question in there that I'm going to have to go and think about at some point. Is it some sort of logarithm thing? It's equal to 1. That looks interesting. Okay. So it's whether the top thing is 0 or the bottom thing is 0, but there's 6 solutions. So what am I missing? Well, the bottom thing is 1, or the top thing is 0, or maybe what else could happen? I can't think. I can only think of 4 solutions, it will. I don't interview CS candidates, so that one on there. Separate interviews of maths and statistics is, some colleges do separate interviews of maths and statistics. Some colleges merge them together and throw in a probability question, see if you can do a probability question. It's the same skills we're looking for. Maths and statistics has the same first year as the maths degree, so we're looking for the same skills anyway. I don't personally interview CS applicants. How did you decide you were interested in maths? Can I have that one? How do you decide to apply for CS maths? Has anybody else answered this one? Let's have a quick look. Flora has recommended looking at the website and the syllabuses of the courses offered. See if they seem interesting to you. Personal story, I suppose. I looked at. I was enjoying maths so much that I didn't like the idea of not learning more maths. I didn't want to miss out on any maths. I was considering doing something like physics instead, or maths and physics, I suppose. But I didn't like the idea. So I thought about what it would be like to do either of those things, and I didn't feel happy not learning as much maths as I possibly could. Right, cool. Interviews are virtual this year. They're online this year, Adam. All our interviews are going to be all our interviews are going to be online. Harriet asked, my school isn't able to enter me for BMOs since it isn't registered. That's fine. That's not a disadvantage. We know that some people do BMO stuff, some people don't. We've got our own maths test, which we think is more useful than that anyway, so you should be fine. You're missing out on a maths competition that has tricky questions in it. You can get some of the questions online anyway, and there are lots of other tricky questions if you want tricky questions. Okay. How would I frame attending these live questions? Yeah, so we're thinking about personal statements, I think. Because if I just say that I've attended them, it might seem like I'm flattering them. So if you just write in your personal statement, I've been going to Dr. James Monroe's excellent MAT Livestream, it's brilliant, and the banter about complex numbers is my favourite part, then that doesn't tell me anything about you, right? So that would be how you flatter me, but not a very personal statement sort of thing to say. I would look, if I was writing about this in my personal statement, which is a confusing thing for me to think about because I'm also hosting this live stream, but if I was watching this live stream with someone else in it, there we go, if I was watching this live stream with somebody else in it, I would focus on things I was exploring, so I'd think about looking at the sheets ahead and looking at the answers afterwards. I would look at the further reading, the kind of extension section at the end of the question sheet, and I would perhaps look at questions that I found difficult, and I would make up my own variants on the questions, just sort of minor tweaks to work out, why do I find this question difficult? What is it about this question? If I see something like this question again, what am I going to know? So I find this question difficult, for example. whenever I see this kind of floor function stuff now, which I've seen in a few places, I'm always thinking about drawing a graph, draw a picture of it. I know that it rounds things down, makes a staircase pattern usually, so I want to draw a picture of it. I know that because I've seen stuff like this before and critically thought, I find this difficult, but it's helped me before to draw a picture of it. So you could tell that story in your personal statement. I think I'm more aiming here, more than personal statement material, what we're trying to aim for with this is being better at solving maths problems, which is helpful, but hard to explain in a personal statement. It's more the sort of thing you demonstrate, I suppose, with solving lots of maths problems. Cool, right, okay. Snap back to reality. I'm hosting the live stream. Question for a friend, is anyone doing a PAT live stream? Or is maths just built different? There is a PAT live stream. There is a PAT live event. Look at the physics department page or check the Oxford outreach page. There's a physics live event. I've forgotten all about it. I was supposed to have an advert here. Let's all imagine an advert here. Hang on. I'm going to do my duty to the physics department. I'm going to look up their event. Let's see if we can find their event. Okay. What I'm doing here is I'm going to go on the internet and I'm going to try and find the physics event. So I'm going to go to Oxford Outreach. Okay, right, cool. What else is going on in here? Question for a friend. Is anything else doing a physics live stream? Flora got the mat light? No, I'm on it, don't worry. I don't know if people have seen this. You don't need to see this because you've already found the best Oxford Outreach event, which is this one. We've got this calendar of everything we're up to. So that's embarrassing. Upcoming events. There's MAT Livestream now that we're watching, and then some more MAT Livestreams. Big Virtual Open Day, I mentioned that one, and some more MAT Livestreams. Anyway, is there a PAT thing coming up? Pretty sure I thought there was a physics thing coming up. Oh, I can't find the physics thing. Right, cool. I'm going to keep searching this. Tightly planned, very prepared. It's a very prepared, almost scripted live stream experience, isn't it? If anybody else can find the link to the physics event, I think I saw it on Twitter. I should not log into my Twitter on this stream. Right, cool. How many interviews might you have? So you could have quite a few interviews, especially if you apply for a joint honours course like Math and Philosophy or Maths and Computer Science, because you might get interviews in both of those things. You might get interviews with a first college and a second college, and then you might get interviews from a third college as well, maybe. So yeah, you can do maths. That could be like 6 interviews. I think the most anyone's had is about 6. It's quite a lot. Cool. Flora says that Flora has a sister. I've got some siblings as well. Look at this question. People are getting like an efficient notation for questions. 4 A levels equals more competitive? Question mark. Very efficient. Answer: no, not really. Because we've got other things to look at rather than your 4th A level. Your 4th A level is probably in something else like music or French or physics. That's less interesting to us than performance on things like math. Cool. So, you've learned some more academic material. You're doing lots of classes, but not everybody has access to 4 A levels. Not everybody's allowed to do 4 A levels. So it tells me a little bit about your school. It tells me a little bit about you, that you're doing lots of work to do your A levels. You're doing that 4th A level in physics or French or philosophy or chemistry or something. I'm more interested in how good you are at maths problems. Right, cool. Will these live streams help me even if I'm doing Tamua? Yeah. Should be. Tamua is very similar to Matt in the questions. Adam saw some Tom Crawford interview questions and thought they were interesting. We had one of those on the Oxford Online Maths Club, which was the project we were running in the Thursday slot before this. Yeah, good question about 2020. Average scores were a bit higher. The exam was maybe a little bit easier. The applicants were pretty good as well. I'm very excited about the applicants. Those applicants have now gone through the rest of the process. They're about to start. We're going to meet them in 2021 for the start of the course. I'm really excited about that. Okay. Is there much decision maths in the maths course? There's a tiny bit of kind of optimization. It's not really related to the decision maths that you do at A level. I mean, we teach graph theory, but without assuming that you've seen any graph theory before. So, Adam, if you're asking, Do I need to? Is the decision maths like A-level decision maths? No, not really. We have stuff like that. Oh, even powers. For getting -1 and even powers. Yes, thank you. There's the 10-minute lag again, by the way. Thank you, Rilo. That's a good question. Thank you, Will. I'm going to scroll back down and look at the coefficients that you put in later, because it seemed like, yeah, -1 and even powers. Great stuff. Good. Right, cool. What are we doing? Good score to get on the maths is about 70 to 75 or more. I guess the more the better, really, but about 70 to 75 sounds good. How many supercurricular things should we aim to talk about in our personal statement? Whatever you're up to, right? So whatever you're doing outside the classroom. We don't count them. We don't put a number on what you're doing. I think you're doing maths and CS. Changed my mind to maths instead because I want to do as many maths options. That's how I thought about it. Yurak. Are you allowed to apply for 2 courses at Oxford at once? No, sorry. You can only apply for 1 course at Oxford at once. What are the most sought after qualifications for a maths applicant? Being good at the MAT. Yes, that's it. You don't have to have any certain competition awards. You don't need to have had any experience with that. The suggestion in brackets is UKMT senior challenges. I mean, that would be quite unfair on all the people not in the UK, but even joking aside, we don't have a systematic way to get your scores from that or to compare them with each other. Can I take a gap year, become a maths whiz, and then give MAT next year? Yeah, so you take the MAT the year that you apply. So if you apply next year, you take the MAT next year. Impedance and circuit, I feel like I already did that one. Switzerland, can I take the MAT somewhere in Switzerland? I think so. Yes, probably. I hope so. If you go on the MAT website and you look for information about test centres, there's a link there on the MAT website to find out about test centres in your country, to find out if there's somewhere you could take the MATs that's already registered, or your school or college could register for you to take the MAT there. Personal view in computers doing proof. Do I believe they're valid? Yes. Do I believe they're as elegant as normal proofs by humans? Yes. No, they're much longer and tend to involve lots of case checking, but also lots of proofs by humans are not extremely elegant. I sort of think that they are proofs by humans. I have kind of weird views on computers, I'm afraid. Maybe I shouldn't go into it too much, but I think that proofs by computers that have been programmed by humans count as proofs by humans. Anyway, which is the ones we've got so far. That might have opened a rabbit hole. Let's not go too deep down that rabbit hole. CS need higher scores on MAT. There are statistics on the computer science website about average scores that their applicants have had recently, Lucas. They do different questions, so it's a bit hard to compare. Can I mention going to the online maths club sessions? Yeah, sure. Tell us about stuff you liked, or what I hope the maths club did was show you interesting maths that became your favourite maths that you then went and looked at over the summer. You had some way to find out more. Can you check that your school has entered you for the MAT? You could talk to your school. You can't check with me. Talk to your school. Please do interview question live streams. Yeah, well, I'm doing one. Not yet. Interviews are miles away. Let's not worry about interviews. They're just maths questions as well, so it's all similar skills. I'm liking this setup. I'm scrolled back in time. Apply to CS at Oxford. Maths in Cambridge, is it still illegal? Yeah, you can't apply to Oxford and Cambridge in the same year either. When are our personal statements checked? So we look at your personal statements when we're doing shortlisting and also later on. But yeah, we look at your personal statement all the way through. We've got access to it at any point after you apply. But we look at it after maths happened when we're shortlisting. Is there any physics AS competition happening this year? I don't know. Am I happy with MAT 2021? Yeah. Oh, okay, let's have that one. I'm happy with MAT 2021. I think it's a good test. I think you're going to like it. Cool. No, you do not need to take maths if you're applying for engineering. For number theory books to recommend, I like Closing the Gap by Vicky Neal. Has somebody already put that in chat? So Closing the Gap is a story about people trying to prove the twin prime conjecture. And it's a story that alternates between updates on how that's going in a kind of narrative style with bits of mathematics. It's got lots of hooks in for you to try bits of maths yourself. The book's called Closing the Gap by Vicky Neal. Did we find the Pat livestream? I did not find the Pat livestream. I was doing quite well at looking it up, but I then failed. I'm going to have one more go. It was not called Pat livestream. This is the most important thing I can work out for you, is I can work out what their event was called. I realised that thinking about it out loud while we were doing it was not the best. Oh, and George has put the link. Thank you, George. No, yes, where's that gone? George has put the link where you can try and find a centre. Note that as well as this link for finding a test centre, your school or college could still, by the end of this month, September, register to be a test centre, I think. Okay. I'm not doing great at finding this. Oh, hello, what have I found? Okay, I'm doing better. Almost up to speed with finding out about Oxford's events. Oh, come on. I definitely saw this on Twitter. But not keen to put my... can I show you MAT 2021? Allowed to see the... Oh yeah, unseen MAT papers from other years. I've got some more questions. I sort of think there are lots of questions on the web already on the MAT website. Yes, this is correct, by the way. The MMath is the same as the BSc, but an extra year afterwards. Can you reapply? Good question. So the answer to say this one, if you don't get in, can you reapply the year afterwards? Yes, nothing to stop you reapplying. Do students who reapply often get in? We don't actually keep data on that because we don't mark people as reapplicants on their application. We don't take information from previous applications into consideration. We don't compare scores. We don't look up facts from your previous application. We treat you exactly like you're not a reapplicant. So I actually don't know how often reapplicants get in because I'm not tracking who's a reapplicant. Good. US versus UK unis for mathematics. Broad sweeping statement. I think the UK universities, to use the US words, we let you major in mathematics from day one so that you can do mathematics only from day one. If that's something you want, then I think there are options to do that in the US, but perhaps that's just sort of normal in the UK that you can major in maths just doing mathematics. Maybe it's even more than majoring in mathematics, isn't it? It's called they're doing an online Q&A, and oh my word, it was at the same time as this. What has happened here? So the event I was thinking of is called Oxford Physics, Ask a Student, and it was on the 2nd of September, which is the day, at 5 PM, which is the same time as our event. Oh, 6:02, so actually just finished 3 minutes ago. What a good thing to find. Let's try and put that on the screen, if I can get it on screen. That's amazing. By the time I found it, it finished 2 minutes ago. Let's see if they've got a link to watch it back. Okay, I'll go to events / student. Oh, it's quite good. It's quite good. Quite a good URL. Oh, found it. Brilliant. Okay, we're on the page. Okay, this is happening. Cool. Here's the physics event that I found. Sort of like a live stream. It finished 3 minutes ago, so we've missed it because you were waiting for me to look it up. It was today. You don't need any knowledge of physics. That's good. We're on physics.ox.ac.uk/events/student-Q&A-2021. And you can register for it. It's for UK students. It's going to be recorded, so if you can't attend live, you can watch it back later. So if you want a physics live event, then unfortunately it was now. Cool, right, brilliant. I'm going to put that somewhere. I tried my hardest to support the physics department. Just turned out to be a perfect clash with me looking it up. Good, right. Okay, we're running out of questions, which is okay. Terrible at expressing myself, but I love maths. Rilo, you're going to be okay because you're going to do some maths questions, and we're always more interested in seeing you do mathematics than talk about mathematics. So that's going to be nice. I believe in you. Right, cool. I feel like I missed some stuff. Do you challenging maths questions on advanced topics, or focus more on the MAT syllabus related challenging questions? Yeah, so I sort of think I get this question. Okay, I've seen versions of this question before. Is it a good idea? So Flora's put a brilliant answer, which is both. It's fine to focus on maths when you're doing math stuff, when you're preparing for maths. I sort of think when you're preparing for maths, doing math questions is obviously one thing you can do. I always get a bit nervous when people are asking for like extra past math questions, extra bits and pieces. I get a little bit nervous that there's loads of other maths not on the math syllabus. So loads of other things that you could be finding out about or trying other bits of problem solving. That's probably more fun, probably more interesting, probably better for you as a mathematician to be trying other stuff that's not on the math syllabus. So I worry a little bit about that. I think between these two, once you've done a few MAT questions, once you've done a couple of past papers, maybe if you're joining us each Thursday for MAT Livestream stuff, other than that, I'd probably start looking at other questions, other stuff to do, other interesting things. Okay. Out of MAT's personal statement and interview, would I say MAT's most important? I think it's close between MAT and interview on that list. In terms of being shortlisted for interview, MAT's more important than personal statements. And then after interview, I think interview and MAT together are pretty important. Maybe interview slightly ahead of MAT, but yeah, okay. I think I interview, MAT, personal statement. People love asking me to rank those items as well. Already asked, but then you missed it. Can you do the MAT in Switzerland? We think yes. People have answered it as well. Perfect. Thank you, community and chat. Cool, good. I like it when people chat as well in the chat. Are the interview questions all A-level content? This is a nice question. So something we like doing is introducing new mathematics or introducing something new, and seeing whether we can teach it to you and you can do something with it. So maybe throwing you in a tiny bit of graph theory that we might show you and saying, okay, now we're going to sort of logically reason with this new thing we've shown you. Sometimes we just do a bunch of algebra or just do some calculations. I personally like questions that involve quite basic mathematics, like A-level style mathematics or even more basic, but get you to really think about what you're doing and think about, as well as doing the calculations, which you should be fine at, as well as doing the calculations, can you think about what it means? Or think about, is there a faster way to understand what I'm doing so that when I get to the final answer, I can quickly check that it makes sense. Which sounds super mysterious. Always talking about interview questions always sounds really mysterious, and then when I actually tell you about the interview questions, it's just sort of maths questions. You're good at that. Right, cool. Flora says no. I'm reading out Flora's response because you can't see it on the live stream. Flora says no, often about things kind of outside A-level curriculum. The interviewer might introduce a new concept, which I think agrees with my experience as well. Ali's got a question for Flora, which is on one of my screens but not the other. Oh, there we go. Next question for Flora. Advice for EPQs. Cool, I can't remember if Flora did an EPQ. We're going to find out. How would you deal with a situation where you can't solve a math problem even after trying for a long time? I think at the moment it's not critical that you solve any given maths problem. You've got other things going on in your lives that are critical and really important, but probably individual maths problems are not kind of critical, you must solve them. Which means you can be quite brave, and if you can't solve a maths problem, you can just put it down, leave it alone, and come back to it in a month. That's not really an option. If it's like your job to solve maths problems, then maybe that's not an option that you can do all the time. But if you've got other stuff going on, then sure, put it down, leave it alone for a month, look at it in a month's time, and see whether forgetting about the rut you were stuck in, being completely forgetting about what you were doing, coming at it again as if you've just seen it for the first time, and maybe forgotten what you were stuck on. Sometimes that can just help. Sometimes just having the kind of instability of looking at the question from a completely different point of view, just because you've forgotten how you were looking at it before, can be helpful. Also, you might have learned some new maths in between. Cool. Okay. So Harriet wants to know about virtual whiteboards, and we used virtual whiteboards last year. I'm hoping that we can use virtual whiteboards again this year. I haven't actually confirmed the technology yet. Last year we used this, which is a virtual whiteboard. You can join in, you can draw on it. It's not worth practicing or learning to get good at online whiteboards because they're all extremely easy to use, especially if you have access to some sort of tablet or largish phone or something. Some schools have got access to tablets and largish devices for drawing on. I've got a kind of graphics tablet, and I've also experimented with a kind of tablet thing that we had in the office, but the tech's not very complicated. If that fails, then our backup plan is what we were doing years ago, which is write on paper, show it to the camera. We've been doing online interviews for years and years because that's how we normally interview people who live a long way away from Oxford. So we've actually been doing online interviews for ages. We're trying out technology where we can, like this, but we have backup plans as well. Cool. Good question. I would not worry about it. It's going to be okay. There's a GCSE kid here. Hello, GCSE kid. I'm getting 30 to 40 on math papers. Brilliant stuff. I'm really glad. So it makes me really happy that GCSE knowledge, you can get 30 to 40 on the mat. I think that says something quite nice about mat questions using kind of quite basic content in places. Not trying to cause offence here, but using content that isn't, advanced A-level knowledge, but using content that you know from GCSE. I like that. That's made me happy. Do you think I will improve if I keep working at this place and take MAT 2022, so that's next year? Yeah, I think you will improve. I think you're going to learn more maths and just have much more experience doing a lot more maths over the next year. It's really scary how much better at maths you get the more you focus on studying mathematics. So if you're doing A-levels that are maths and further maths and something else, then you're spending a lot of your time doing maths, and it's just sort of almost scary how much quicker you can accelerate at getting better at maths. I'd be really proud of 30 to 40 on the mat, GCSE knowledge. Cool. Oh, suppose there were two applicants. Oh, I said, another sort of good start to a question, isn't it? One with very high potential, but less experience or knowledge. The other had massive problems experience doing maths, but no outstanding potential. I think potential is quite closely linked to ability to solve problems. Yeah, I'm not sure this one quite works. I think the one with lots of potential to do well on our course, even if they've seen less mathematics, I think that's quite exciting. Is that the right answer? When so this question asked me to compare applicants, potential to succeed on the course is the phrase I use to try and sum up what I'm looking for, people who are going to do well on the maths course. Why are interviews online when masks could be used instead? So we're also concerned about getting lots of people into Oxford from all over the place. Usually in a normal year we bring everyone to Oxford, they'd stay for a few days, they'd have meals and accommodation as well as the interviews, and then disperse around the world again. We didn't think that was a very good idea this year. It's not just about masks during the 20 minutes of interview, it's about getting everyone in, having them here for a few days, doing food and accommodation at the same time, and then getting everyone out again as well. It just felt like a lot of travel, a lot of being near each other. Okay, a little bit cautious. Cases are a little bit high in Oxford, or they were a couple of months ago last time I checked. Okay, I'm thinking of writing my EPQ on conic sections. Okay, nice. Do I have any recommendations for books or theorems to look into? Not off the top of my head, sorry. No, but conic sections is a nice idea because there's lots of stuff you could write about. You could talk about the thing where if you've got a cup of water and you tilt the cup of water and the surface makes, you might expect it's a weird complicated shape, but the surface is an ellipse. If you have a paper cup that's a cone, same thing. So if you hold it straight up, then the surface of the water is a circle. But if you take a cone and you tilt it, then the shape you might expect it to be something weird. It's an ellipse. It's kind of nice. You could look into why that's true. I mean, if you know the phrase conic sections, then you probably know why that's true. Good. Simon Singh, the username Simon Singh says, why do people get interviewed with around 50 marks, but not everyone around 70? Is it based on backgrounds? If so, do people who are privileged need to get higher marks to get in? Privileged didn't quote marks. We like to look at the context around your application as well. So MAT is important, but we know that there's other important contextual stuff going on as well. Also, sometimes that context is really important, right? If I apply, then I think I would get quite a good score in the MAT that I've written. There's some context there that's really important. I think we can agree, right? If I apply, I'm going to get 100 on MAT, but I don't think I should be shortlisted for interview. Cool. That's another if I was watching the stream sort of moment. Right, cool. What I said, personal statement is more important for maths and philosophy applicants than just for maths applicants. I think not really. So the maths and philosophy applicants also need to be good at maths. Is it more important? Gosh, I guess we have that kind of philosophy interview as well. So let's say a little bit. Should we focus solely on the multiple choice questions and a little on the longer questions to get an easy 40-40? Meaning we only need around 35 on the long questions, or spread them across. Right, look at this question. Oh my word, this is strategy here. So this person's talking about trying to get 80 on the MAT. Their plan is to go full on the multiple choice questions at the start, ace those, get 40 marks, and then get 40 more marks on the longer questions, which I suppose is an aspiration that you can have. The multiple choice questions are not trivial. This one's quite tricky. It's going to take me longer than 6 minutes. It might take me 12 minutes. It might take me 15 minutes. And if it takes me too long, then I'm not going to have time to get 40 marks on the other ones. So you could try this out on some past papers. Once we get through all the syllabus stuff, we've got some practice papers we're going to try together at the later on in October. You can try this out if you like. It's a strategy that you could try. We do also get that data as well. So you also get to see, we get to see where you got your marks. We don't really care because we already worked out how many marks to make everything worth, but we would have that, I suppose. Michael, so if you're an Oxford applicant, if you applied to Oxford, you get an automatic email in January after the MAT, after all the decisions have been made. At the end of the admissions round, you get an automatic email from the University of Oxford with your MAT score. If you applied to maths, it is from me. Harriet has replied saying, I believe it's the 29th of November, but unfortunately that's not true. I don't put mid-January. Sorry. We wait until all of the rest of the results have come out. We send them to other universities, 29th of... we send them to other universities in November, but we don't send them to you until end of the admissions process, which sounds weird now that I say it out loud, but does make sense, I promise. Cool. Done some open courseware. Can I talk about it in personal statement? Let's have a kind of general answer to this sort of question. If you've done it and you think it shows that you're great at maths and you're prepared for university mathematics, sure, you can talk about it in your personal statement. That's sort of what the personal statement's for. Doesn't really matter what it was, whether it was online or in person, or some maths you did on your own, or a book you read, or a film you watched, or some online rambling that you tuned into at 7 PM on a Thursday. You can tell us about it. The MAT is currently scheduled for the 3rd of November. Yes, that is when the MAT is. Cool. I think Flora's still here. Flora, you're a hero if you're still here. Flora's, I think, still here moderating chat. Flora has gone back. So somebody asked a couple of hours ago what Flora scored on the MAT. It was ages ago. Flora's gone back to find out what Flora's MAT score was, and Flora has found out that Flora scored exactly 69 on the MAT. So there you go. Flora, if that's not you, then you moderated it, so I'm assuming that is you. Cool. Oh, Flora went to go and find the email with the MAT score. Right, cool. Good. International students Okay. Some sort of question about scholarships. This question is about your situation, about whether you can accept the offer if you can't pay the tuition fees, despite applying not getting any scholarship. Yeah, I think that sounds true. Right, cool. If man is most important. Oh, it's the same question again about privileged people. The question's getting a bit longer. Can I just reference the topic? I watched a machine learning lecture. I'm getting tired. I read that as a washing machine lecture. Do you prefer it mention the author any timestamps? You do not need to be too specific. You don't need to give timestamps or citations. It's okay to say vaguely what you did, and then focus on what you got out of it, I think. So I think the phrase "watched a machine learning lecture online" has enough that I kind of understand what you did. Well, maybe. I'm assuming you watched a machine learning lecture online. If you then also thought about it and tried writing some simple code to do a little bit of machine learning, then that could be your next sentence. Which is more interesting to me than I watched this YouTube video, link at timestamp, blah. I'm not going to click the link, so don't include links. Anyway, pen recommendations for the MAT. You do have to answer in pen. Does Imperial College computing require MAT? Oh goodness, I think this is a question for Imperial College. Something about it in the open day. Hopefully the Imperial College open day, talk to Imperial, it's up to them which of their courses use the MAT. I think, no, I'm not even going to guess. Rilo and B are doing some maths. So good. Harriet's got a question about timings. Harriet, I normally recommend that people spend about 6 minutes on each multiple choice question, based on some really back of the envelope calculations about how many marks there are on the maths. That's not an actual, to be clear, I'm not recommending that you time it and after 6 minutes do the next question, after 6 minutes do the next question. That's a kind of rough, maybe spend about an hour on the multiple choice questions sort of idea that I have. I think in practice people flip between the two, so there's a bit of that going on as well. Good. MAT is in person this year. Last year's MAT was in person for almost everyone. We arranged an extra mini MAT for a very small number of people online. But yeah, MAT in person. That works because we think that each test centre has got a very small number of people doing the MAT, so it's not bringing that many people together. The long questions are all 15 marks. Each of them is 15 marks, so they add up to 60. Good. Okay, Ali, would you say it's worth taking the MAT long questions to step preparation? I think yes. I mean, if your only aim in life is to get a really good Tamua score, then I guess Tamua papers and a really close study of the Tamua specification. MAT long questions, I sort of think some of them are interesting and good, and you can use them to get better at solving maths problems. You could interpret it as several short questions stacked together with a theme, which is, I guess, not how Tamua works, but yeah, go for it. Is it good for step preparation? I'm not sure. I genuinely don't know whether this is useful for step preparation. Step questions are all long and have lots of stuff that you're supposed to do. If you're doing step, it's at the end of year 13, so you've got lots of time to think about step questions. Cool. Right, I'm going to wrap up in a minute because we're getting up to 7 PM where I am. It's a question about Minimat. Why did we make the Minimat last year? Well, there was a pandemic on, and some people couldn't take the MAT in their test centre, so we made in a hurry, we made a small version of the MAT, which we did online with some people through online invigilation. We wrote 10 extra short questions. That's 10 additional short questions, which we did with those people in between MAT and interviews, which is why we did that, because they had been unable to take the normal MAT due to coronavirus. Okay, right, let's do, I pronounce it Tamua, like Sokotoa, right? I don't know if everyone pronounces it Tamua. I mean, I pronounce step and I pronounce MAT, so I guess I've got to try with Tamua. I've heard other people say Tamura as well. I think it's not just me. Which is, yeah, okay, good. Right, cool. Maybe we'll wrap up there. Is there anything else? If your question is currently awaiting moderation, then I will type an answer to it off stream. But I think so that I can type proper answers, so I can let Flora go home. Thank you for watching Matt Livestream. We're going to be back next week with, I think it's integration week next week, which is a big one. This one's been quite nice and chill on logarithms. Lots of integration stuff to talk about next week. That's going to take place on September the 9th, 5 p.m. UK time. The worksheet's already up if you want to look at the questions that we're going to cover. The solutions for this one are going to be posted tomorrow. Thanks for coming along. Thanks for answering the poll questions. I think we did really well at logarithm questions today. And I'll see you around. Bye. And if anybody's seen this before, you know that I am terrible at switching things off. Yes, good.